Number 6 here, our last one, had an extra one thrown in this time because we had so much to do. So number 6, we've got a titration curve of para-aminobenzoic acid here with the sodium hydroxide, and the equivalence point is quite clearly marked right here at 50. And if we know the equivalence point, then obviously we know the midpoint of the guy here. And it wants to know a little bit about what's happening here at 40 milliliters. Well, remember what we talked about, that if you are talking about the starting point, which is here, I'll put it in a different color. If you are talking about the starting point, the only thing that you have present is HA. If you are talking about the equivalence point, the only thing that you have left is A minus. If you are talking about the midpoint, that is right here, you have a buffer system where the HA and the A minus are the same. And then if you have anything in this zone or anything in this zone here, you have a buffer system where you have varying degrees of the acid and the base. If it is to the left of the midpoint here on this kind of a graph, then you are going to see that you're going to have more acid, which makes sense because the pH is lower. You're going to have more acid in the base. If it is to the right of this kind of a system, which it is in this case, then what you're going to have is you're going to have more base than acid, or you're going to have less acid than the conjugate base that's here. So at 40 milliliters here, then it looks like looks like I got a typo here. It should have been this guy here. So I'll fix that to make sure that on yours it's right, but on mine it's a little bit different. But I have two answers that are the same, which doesn't make any sense. So it should be D, where the acid is going to be less than the conjugate base that is there. And again, don't be scared of this ugly looking formula here. So this formula is HC7H7NO2. That is a lot going on there, but in reality, this is just HA. All of that is just the A portion of HA. And so when you start to look for the conjugate base of something really ugly looking like this, all you're going to do is remove a hydrogen and add in the -1 charge that you need. So your conjugate base of this system is going to be C7H7NO2 negative. That is your conjugate base for that weak acid here. So D is your best answer here. A buffer where the acid is a little bit less than the base because you are past